I was introduced as Chris Bohn, but I actually go by my initials, CB. Even my mother calls me CB. So that's fine. If I've worked at Etsy a long time. If you were to go to Etsy and ask anybody, oh, do you know this guy Chris? They'd say, who? But if you said CB, they'd say, oh yeah, I know that guy. All right, so what we're here to talk about today is how Etsy is migrating from being an on-prem site to the cloud. Lots of adventures here. Yeah, don't know what's going on here. Okay, so I'm going to tell you what this talk's going to be about a little bit. First, we're going to talk a little background about Etsy and me, and then why we're moving to the cloud. We'll talk a little bit about our architecture. We'll talk a little bit about production versus analytic data, because that plays into this. We'll talk about cloud economics, tips on deploying an application to the cloud without paying too much money, which is really the whole key here. Then I'll have some questions, and we'll have a little quiz with prizes, so pay attention. So, how many people here have heard of Etsy? Okay, for those who don't, Etsy makes a marketplace for people who make their own handcrafted stuff. Believe it or not, there's a lot of people out there who make their own jewelry and clothing, and they sell it on Etsy. And it's pretty huge. So I didn't make this slide. This is our marketing department. So of course they came up with this slide, which I think is probably the most confusing thing around. It's got, you got your seller up there, and then we facilitate a transaction between the seller and the buyer. And then we make a bunch of investment to make sure the whole thing works. And so they make me show this whenever I give a talk. So I've done that and fulfilled my obligation. But basically what we do is, I'm sorry about this, it keeps going to small size. All right. So some fun facts about us. Founded in 2005. In 2016, we had $2.8 billion in sales. That's a lot of handmade stuff to sell. In 2017, I didn't update these numbers, but it was about $3.5 billion, I believe. Etsy's really, really growing fast. Back then I think we have over 2 million active sellers now, and there's like 40 million buyers. These numbers are pretty much the same, 66% mobile. Mobile is more than half of our purchases. International is about a third of our business. 87% of our sellers are female. And we've got 500 terabytes, half a petabyte in our analytics stack. And that is the analytics that our data analysts query. We actually have a whole bunch more data, and we'll talk about that. So, Etsy is headquartered in New York City. Anybody been to New York here? All right, good. So this is on the Brooklyn side of the East River looking towards Manhattan. And that's the Brooklyn Bridge right there. And it's really a nice spot in New York. And I probably know New York City better than anybody who's never lived there, because I don't live there. Yeah, I live here. I live in San Francisco. And I work remotely for Etsy. And I've done that for more than 10 years. So I fly out to New York every 2 months or so, and I spend 2 weeks there. I spent over the past 11 years, I think I've been there, I spent about, I don't know, 150 weeks or something like that. It's more than 2 years worth of time I spent there. So I go out there a lot, and it's really fun, because I go in there, and as they say, like fish, you both begin to smell after a while. So I go out there, and I spend my time at Etsy, and then we're both done with each other, and I fly home to San Francisco. All right, so why are we moving to the cloud? And why do we have to move to the cloud? Why aren't we already in the cloud? Well, we were founded in 2005, and that was before any commercial cloud was really out there that was any good. So back then, you had to, what I call, roll your own. Now, I'm going to use a few English or American expressions here, and I'm going to try to explain them, but if someone doesn't understand what I'm saying, feel free to interrupt me. Does anybody know the expression roll your own? I'll tell you what it means for those who don't. If you smoke cigarettes, you can have cigarettes in a pack, and they're already made, or you can buy loose tobacco, and you take a paper and you roll it. So you're making your own. So when you say roll your own, that's something you're doing completely on your own. You're not buying anything. So there was no cloud, so we had to roll our own data center, which we did. And then why do you stay in it? Well, it's momentum. You know, you make this big investment in a data center, and it's your own stuff, and it's just easier to stay in that. It's like being in a relationship. It's one of these things, maybe you've had this experience, you're in a relationship and you say, God, I've got to get out of this relationship. This is terrible. But then you say, oh my God, I can't go through all that crying. I got to stay in this relationship. And so you just stay in it until something really big happens. Okay, whatever that is in a regular romantic relationship, something happens and then you end what you're in and so forth. You know how that works. For us, what happened is that we're a public company. We trade on the NASDAQ exchange. And we had a hedge fund investor called the Black and White Investment Fund. And they put money into Etsy, and they own about 4% of the company. And we have another expression which is the tail wags the dog, which means that if someone gets something just a little bit, they've got a lot of leverage. So what they do is they threaten to go to all the other shareholders and get a voting majority to change the board, change officers or whatever. So they have a lot of power. Anyway, they came out and they said, we really think you guys ought to be in the cloud. You're spending too much money on your infrastructure. What they don't realize is that going to the cloud is really not about saving money. In fact, going to the cloud is really expensive, and I'll give you an example. You've all heard of Snap, right? So Snap, when you go public in the States, you have to put out a document called a 10Q. And part of the 10Q is it explains to potential investors what some of the risks are. And they put in there as a risk that they were hosted completely in Google Cloud. Everything was in Google Cloud, and that they were committed to spending $3 billion over the next 5 years on Google Cloud. Okay? That's a lot of money. They got criticized for being all in one basket. So then they did another deal with Amazon AWS, and so now they're spending another $1 billion with them, so it's $4 billion over 5 years. So that is not cheap. That's an expensive cloud. So it's not really about being cheaper. What it's about is being more nimble. And I'll give you an example. Last year, we upgraded our Vertica analytic database, and so we spent $1 million on hardware. We got 40 new servers with 1 terabyte of RAM in each. We ordered it in January, and we weren't able to install it until June because it took that long to get the order in we bought them from Dell. It took forever to get them. And if we were in the cloud, we could just push a button, and the same day we'll have more servers around. So it's really about the speed. Some little startup can be much faster than Etsy because they're not burdened by being on-prem. They can just use the cloud and deploy stuff really quickly. So, important point to remember, it's not about saving money, it's about being quick, what we call being nimble. So, our planning. That investor reached out last year in the spring, and our executive team decided, okay, we're going to move to the cloud. So we did an extensive review of cloud providers. By the end of 2017, we made our decision, and we decided to go with Google Cloud Platform. And we set a target of the summer of this year to move our production servers to Google Cloud. And then we've got a goal of moving the analytics part next year. And I'm going to talk mostly about the analytics side of things, because that's where I live. But we did move our production servers about 2 weeks ago. On August 19th, they did a first attempt. Now, they had done everything, and they said, okay, we're going to go down for 4 hours, and we're going to switch the servers over. They were running them in parallel, on-prem and in the cloud. And they switched it over, and it lasted about an hour, and then it died. So they had to roll back. Then they tried a week later. They fixed some stuff, and they flipped the switch. It's still running in parallel, but now when you go to Etsy.com, the web servers and the databases are running off of Google Cloud. We still have a parallel set up in our on-prem location just in case things go terrible, and we can revert, and it's got the same data, so that's good. And that's something you got to do. If you're going to make a big switch like this, always make sure you got a plan. You got to be able to back up. All right, so a big thing about going to the cloud is something called elasticity. And I'm going to define it this way. It's the ability to grow or shrink deployed computing assets, servers, in the cloud. And understanding elasticity is the key to understanding efficiency in the cloud. Because the whole idea there is that you can add more servers or take them away as you need for your business purpose, and that is how you manage your expenses, as we shall see. Just mention briefly about our infrastructure. Let's see if this thing... Does this have a pointer on it, do you know? Is there a... No? That's okay. Don't worry about it. Okay, on the top here, this is our production. So there's the internet. If you go to Etsy, you go through the internet, you hit our application layer, which is written in PHP. We wrote our own ORM, Object Relation Manager, for that. Those guys talk to our MySQL databases, and then the data goes back out to the user. And then the MySQL stuff is replicated into Kafka. We wrote a bin log reader. Basically, it hangs off of some MySQL downstream servers, and this daemon reads the bin log and produces them into Kafka as topics. So all our tables then are moving through Kafka as a topic. And then things like Vertica and HDFS can subscribe to those topics, and that's how we get our data into these other systems, is through Kafka. That's become a really, really big system for us. But there is this big dividing layer between what's in production and what's in our big data stack. You know, the production stuff is what our customers use when they're interacting with the site, but our internal scientists, data analysts, financial people, they're all on this side of that line using Vertica and Hadoop stuff. Okay, cloud economics. Really important to understand this stuff. So the charges that you get when you're in the cloud are a combination of CPU, storage, and network usage. They combine those things together and they give you a bill. And that can really, really add up. If you start out, maybe you can pay as you go. Oh, we use this much CPU storage and network, and they sort of meter that. But once you get beyond a certain point, you're going to want to have a flat fee. And that's where elasticity can help you. Because if you're being charged, you don't want to be charged for stuff that you're not using. Okay, and so OLTP and OLAP have different economics in the cloud. OLTP is online transaction processing. OLAP is online analytics processing. OLTP is what I showed you with the production side of things, and OLAP is the big data side of things. And that's shown here. So top of the line there, you got your transaction processing. You know, you got your business processing, which is basically your application layer. It talks to your relational database. That stuff then makes its way again through Kafka into the data warehouses down here. But there's a lot of difference between these two things. Here's the big difference. Online transaction processing databases are designed for fast transactions, to look up records, single records really, really quickly. So something like MySQL or Postgres, they have indexes which find a single record very, very quickly. And that's important if someone's buying a product, they want to find the product details really quickly, and they're interested in a specific product instance. And so that's really good. But that's terrible for aggregation, as we'll see in a second. And then OLAP databases are designed for fast aggregation. They're for doing things like, what's the total sum of all the money spent in the past week on Etsy through purchases? If you try to do that in MySQL or Postgres, that is an expensive query to do, because generally those databases can't make use of the indexes that are there. And so it has to do a sequence scan. Okay, so let's compare two of these two databases that are on the analytics side. These are OLAP databases. One's on-prem and one's in the cloud. So we've got Vertica. Who here has used Vertica? Okay, great. It's a pretty good database. It's a columnar store. It came out of academia, and it's really good for aggregated queries and analytics. And so we use that for all of our analytics stuff. The analog for that in Google Cloud is BigQuery. And it's a very good database also for analytics. It has some drawbacks. It's not quite as good, in my opinion, as Vertica, but it's getting there. And we actually use both, and we use them for different purposes. One big difference between being on-prem and being in the cloud is that when you're on-prem, you've bought the hardware, you're paying for power, but your analysts can run all the queries they want. It's not going to charge you any extra money. But once you're in the cloud, they're generally charging you per query. And the way they actually do it is by how many bytes are read off disk. So if you have analysts out there who are experimenting and maybe they do a query that reads a lot of data, that can be very expensive. So you have to plan for that. Okay, so for Elastic online processing, you can achieve elasticity by partitioning your workloads by vertical classifications, your finance, analytics, etc. It's difficult to apply that to online transaction databases, but it can be applied in the application layer. What I mean by that is, let's say you've got 100 MySQL servers. You can't just shut down 50 of them because you're going to lose data, okay? But you can shut down your application web servers because they're not saving any data. They're just processing logic, business logic. So, hits that are coming in from users out in the internet, instead of that being distributed out over 100 servers, maybe you can reduce it and it's just 50. But you got to keep the number of databases the same, or you're going to have to rebalance your data across a different number of databases, which can be really painful. And if you're going to go this route where you're sort of partitioning use cases, then you need to do good scheduling to make sure that the spin up and the spin downs of those things match what the needs are. Talk just a little bit about relational database indexes. So the way this works is student ID there in this table, that's the primary key. And these lines in the middle, these arrows, that's like the index. And these yellow pages here, those are the pages on disk where the data is stored. So if you look for student ID number 6, for example, the index will say, okay, it's on this page over here. And then the database will know to go grab that page. And it'll read that page and grab the data. It's just like a book. If you use an index, it'll tell you, well, this information is on this page. And you go to that page, and there it is. So again, that's really great for finding a specific record. Now, this is how a columnar database like Vertica or BigQuery runs. There is no index. Instead, the way it gets its speed is by sorting and ordering the data on disk. In this case, and it does it from lowest cardinality to highest cardinality. The most efficient index in a regular relational database is on a high cardinality column. That's why primary key, by definition, has the highest cardinality, because everything is unique. It has to be. But here, we're going kind of the inverse. It's more efficient in this type of database to work with low cardinality columns, because what happens here is, in this case, we've got this column gender, and there's two choices, male or female. And so the way this works is the database will arrange the data so all the female data is stored together on disk, and there's some metadata on top of that that says how many there are. Same with the male data, okay? And then if you go from left to right, you can then funnel through other criteria. The middle column there is for the class level in a high school, freshman, junior, sophomore, and senior. So if you want, the number of female juniors, for example, well, it can go find females and then juniors. It can find that really, really quickly. So here's an example query. We're just going to go through this really quickly, but select count from students where gender is female. That would be really, really tough to do in MySQL because it's correlating on the where clause there on gender. Well, there's only two choices, male or female. And an index isn't going to help you. MySQL is going to say, you know what, I can't use the index. I'm just going to read the whole table data from start to finish. That's a full sequence scan. And that looks like this. It can't do it because it can't make use of any of those pointers. It's got to start from the top and work its way down. Whereas with the columnar database, for gender, it can go down to female. It knows from the metadata that there's 6. If it's also looking for juniors, then it's just a one hop away to get the juniors, and that's 2 steps to find the answer instead of having to query the whole table. So that's the difference there. Now, if you were to use this columnar store database to try and find an individual record, it'd be terrible. But for aggregation, it's really good, and that's why there's really a big difference between production and analytics, as you can see. Okay, so disadvantages of OLAP, because of the way the data is sorted and stored on disk, if you do an update or delete, it's very, very expensive because I told you that the data is clustered together in storage on disk, and it's in what they call storage containers. Those are like files. If you were to update a record, what these databases do is they have to go rewrite that entire storage container. So it'll read in all the data, and then it'll make the adjustment and then write it back out again. That's really inefficient. And it can really kill an analytic database. So if you're designing your systems and you're going to be using an analytic columnar database like this, try to make your data so you don't do any deletes in your production data if you're bringing that over. Because if you don't do any deletes, you don't run into this problem. So this is a key point you need to remember. You design your data to minimize update and delete. You will be much happier if you do that. All right, so optimizing the server deployment in the cloud. You need to use Elasticity to grow and shrink your deployed servers to meet your current demand. For example, let's say that we've got a database and we've got 20 nodes in this database cluster and it's being fully utilized. Okay, that's good. We're paying for 10 minutes. Are you kidding me? Okay, I'll try to hurry. If you've got, 10, let's say 10 database nodes, and it's being fully utilized, that's great. You're not paying any extra money because you're being billed by usage of these assets, computing assets. But if you're only using half of that capacity, you're still being billed for the full 10, but you're only using 5. You're paying for 5 that you're not using. That's a big waste of money. So you can either shrink down those that from 10 to 5, and you can do that because of Elasticity. You can just go into Google Cloud or any of these clouds do this and say, hey, this cluster I've got that's 10, make it 5, and it'll adjust itself that way. Or you can divide your application up into verticals. We're going to talk about that in just a second, but that brings in some scheduling issues. Okay, so cloud server provisioning. This is a usage graph. The blue bars are utilization of what we've got deployed in the cloud. So at midnight, where 0 is, we're only using about half of the computing power. Okay? But when you get over to noon at 12, we're using 100%. So at noon, we're very efficient, using 100%. But at midnight, we're not efficient. We're only using half. And that red you see up there, that's the computing power that you're paying for but not using. And if you show something like this to your boss, he's probably not going to be too happy. On the other hand, if your boss comes to you and says, hey, how can we save some money? We're spending a lot of money on the cloud. Then maybe you can whip up this graph like this and say, hey, look what we're doing here. We're actually underutilizing. We're over-provisioned during certain hours. So let's adjust with elasticity, let's adjust the number of servers we have, adjust them down so that we're 100% utilized during every hour. And he'll probably say, great. And you can say, hey, you see that red stuff? That's money we're saving. So key point, you can reduce your over-provisioned stuff and save money. So rethinking our Vertica architecture in the cloud. So the way that in enterprise Vertica, which is on-prem, works is that you can create these resource pools, which are basically just a collection of things like runtime maximums, what the parallelism is, and so forth. And then you assign users to that. Okay? In the cloud, Vertica realized, wow, you know, if people just bring Vertica from enterprise into the cloud with the same number of servers, they're going to have that problem where they're going to be over-provisioned during certain times of the day. So they came up with this Eon mode thing, which allows you to shrink and grow or add a plurality of clusters that talk to the same underlying data storage. Okay, that's really, really good. Now, Etsy currently has resource pools for ad hoc, which is what our data analysts use. We put them in that pool, and they're free to use that. Then we have our ETL tools, which is resources just for the data to move into Vertica from production. Our finance people have their own pool. We use Looker, which is a visualization tool. We do roll-ups, which are basically pre-aggregation materializations. For example, a common one is we want to know for every seller on Etsy, what's their total sales to date? And we don't want analysts running that query within every one of their queries, so we roll that up every night into its own table, and they use that. And that saves a lot of CPU cycles. Okay, so how do you partition into verticals? Those colored vertical bars there are the verticals. Now I put a little dotted line around the purple one because let's say that that's our roll-ups one. Now we only do the roll-ups at night. We do them at like 2 a.m. and they run from like 2 to 6 in the morning when there's low activity. We don't use it at all during the rest of the day. But when we're in the cloud, we may have 10 servers dedicated to that. Well, we can just shut that thing off. We can just tell the cloud, hey, you know, get rid of this. Get rid of this, and then we'll fire it up again, rebuild it at 2 in the morning. That happens really quickly. We'll run those roll-up jobs, and when they're done, then we get rid of it. And we're only paying for the time that this vertical is up. I think this is actually learned from Uber, because this is how Uber does their business. They're a big Vertica user, and they have several verticals that are dedicated to their user groups, because when you have resource pools and one big cluster, they can interact and influence each other. This is good because these are completely separate clusters, and if you're running some really intensive queries in one, it doesn't impact the other one. So you actually get better performance, and you get better economics if you do things this way. So the takeaway here is when you're designing an application, if you can design that app so that you can divvy up the workload so that you've got several applications that you can turn on and off, then you're in a position to optimize your usage of cloud assets, and your costs are going to be less. And so that's what we're doing. We're right now designing our architecture for how this is going to work, and we'll be deploying that next year. And I think I'm just about out of time here, if I'm not mistaken. But that's okay, because I'm going to take questions now. Someone's got to have a question. I came 10,000 miles for a question.
Yeah, hi. So you've told us about these verticals and how one can shut them down, but especially relating to databases, everybody is afraid to even touch them, even if it's master or a replica. If it's running, then it's running, and even if it's big and is used at about 10%, it's really crucial. One cannot shut them down. So how is the scaling achieved? Because cloud provisioner also takes time
right.
to provision these resources, and especially not destroy them.
You're going to see more applications go this way towards verticals. If you look at like BigQuery in Google Cloud, it's already built in. And that's why companies like Vertica said, wow, we got to do the same thing, because if we can't do that, then we're going to get beat out by BigQuery, which is a competitor, because they've got better ways to manage the economics of using this stuff. I showed you a picture earlier about our architecture. We've got the web servers and they talk to the database. That's kind of how this is, but imagine that those verticals are kind of a front-end web server to the data, okay? And you can add more or take them away, all right? And it doesn't matter, because the storage is what's really important. The storage stays the same. It's the application servers that are interacting with the storage is where you're going to save the money. I hope that answers.
So you are, when you say scale, destroy, and provision, you mean the means to get to the assets, not the assets themselves. They are stored elsewhere. And
yeah, I mean, for the roll-ups, I use the roll-ups as an example. Let me go back to this. So we only need that roll-ups during 4 hours at night. So why have it sitting around just idling? It's like having your car sitting outside your house with the motor running all day, okay? You're paying for all that gas? No, you're going to go and turn it off, right? So that's what this is. When we shut this thing off, what Google does is says, oh, you don't need those servers anymore. We're going to now give them to somebody else. And then when we start it up again the next night, Google says, okay, yeah, we've got some servers here, and we'll give you the 10 servers, and they rebuild in a very short period of time, and it's ready to go. But the whole key here is that Vertica built their database because they want to be able to do this and be elastic. Okay? If you just take regular Vertica and move it to the cloud, you're stuck with the number of nodes you had on-prem. It's only because Vertica designed it to be able to do this that this happens. If you take MySQL, for example, you can't do this. You have to, if you want to add more servers, let's say you have 10 MySQL servers, and you say, oh, we need more capacity because we're really being slammed right now. So you say, okay, let's add 10 new servers. Well, you've got to rebalance that. If your server is sharded like ours is, you've got to rebalance it. And rebalancing data across servers is really painful. Okay? It's just not efficient to be able to do something like this. But here, the data is all saved in the shared cloud storage. And every one of these verticals is talking to the same storage. So what's happened here is a separation of the compute part and the storage part. You'll read about this if you read about any of the clouds. They'll say, oh, we've separated compute from storage, and that's what that is. You got the storage here, it stays, but the servers that are talking to the storage, that's what you can deploy and destroy, shrink and grow.
thank you so much.
Okay.